Sometimes tutors will teach like the shortcut, and it's fine, or siblings or whatever. Now everybody gets to know it. Okay. Okay, remind me, what is the derivative again? It's the slope of the tangent. Okay, so if I have the derivative of a, whoops, that was supposed to be a highlighter, of a constant function. Okay, what would be an example of a constant function? It would be like y equals 3, right? What does y equals 3 look like? Just a horizontal line. Now I just picked 3. I could have picked anything, right? I could have picked square root of 2. I could have picked 100. No matter what, it's just a horizontal line. Well, think about what's the slope of a horizontal line? 0. So that's why the derivative for any constant is going to be 0. So my derivative here, oh, why did I put 3? Sorry. Derivative of 3 is 0. If I say d dx of pi, that's 0. Okay? So anytime you have a constant, it's just 0. Okay, this is the big one. This is the power rule. This is the one that maybe someone taught us. Okay? It's when you have x to any positive integer, and what we're going to find out later, it's really for any integer. So we have x to the n. Basically what we're going to do is we're going to move that exponent to the front, and we're going to take one away from the power. So for example, x to the 5th becomes 5x to the 4th.
And that's the slope. And that's the slope. And that's the derivative.
That's the derivative.
So now we don't need to do anything else.
You don't have to show the work.
Why is that? Like, how does that happen?
It's a bad question.
It's not a bad question. Listen,
It's a long question.
let's take f of x. I'll give you another example. F of x equals x squared. Okay, remember that last quiz, that part B? It was a parabola, wasn't it? Half of it was a line, the other half was a parabola. What happens, I'm going to just, it's going to become 2x to the first. So that means the tangent, so we have a parabola. Every single time we do the derivative, right, if it's an x squared, that is, it's just going to become 2x. It's the equation of a line. Yeah.
It doesn't matter if it's 2x squared or 3x squared, doesn't matter.
So let's look at the next example, because I have a 4x squared there. You guys like to jump ahead. Okay, constant multiple. Do you know what a constant multiple? Just, in other words, a coefficient, right? If you have a coefficient, you can just move that out in front. Now, I typically don't even bother writing this out, but I'll just kind of show you. So this next one, I can move the 4 in front, and I'll do t dx of x squared. But what's the derivative for x squared? We just did that, 2x. So I would have 4 times 2x to get 8x. Now, this is the only time I will ever write this all out. Too much work. Couldn't we just move the 2 in front to multiply to the 4? Okay, that's how we're going to tackle that. Okay, good so far? Not too bad. So much better than those limits, right? Yeah, Ben, you got a question?
Yeah. What if it doesn't matter if it's x to the 1? Like, is that something else? Like, what does it go to 0?
So let's think about x to the, so if I have y equals x to the first, let's see what happens. The 1 moves to the front. I get 1x to the 0. Oh, sorry, I forgot. Which is just? Now. Okay. Isn't this the equation of a line, y equals mx plus b? What's the slope of this line? 1. If I had y equals 2x plus 3, what's the slope? Right. That power rule still works. It's just easier to just interpret the slope. Okay, sum and difference. This is really easy. It just means that you can distribute taking the derivative. Okay, so here I have 4 plus 5x cubed. So I'm going to take the derivative of 4, 0, good, plus 15x squared. Yes.
How is 4 0?
Okay, 4 is a constant. Anytime you have a constant, that was the very first rule. Just think, if I have the line y equals 4, what's the slope of that? It's 0. Just remember, anytime you have a constant, we're trying to take the derivative, just goes away, becomes 0. Okay. All right, we got this. Okay, it says find dy dx. Now remember, we talked about all those different ways to write the notation. You can just write y prime. I think I'll write this one out, dy dx. I don't really have a preference, so when you're doing homework, if it's y equals and you want to do y prime instead, I'm okay with that. All right. You want to give it a try?
Sure.
Ah,
The fractions
the fractions are fine. Okay. Did you try it? Oh, let's see. Yeah, let's see here. What's going to happen for the first one? It's going to be 12x cubed. Good, minus 18x squared. Okay, so the 2 is going to go in front, so the 2's will cancel, so I'll just get a plus x to the first. Okay, the next one, minus, it's just going to be minus 1/3, okay, because it'll become x to the 0, so that goes away. And then the plus 10, that's just a constant, so that.
You don't want to combine the 10 and the...
That's it, that's it. I know, it seems too easy.
Wait, sorry, why aren't you including the one?
So the very first rule we did was derivative of a constant is 0.
Oh.
Because think of each of these as its own individual, like when you get to the minus x over 3, think of that as a negative 1/3 x, like if you were to graph it. So it's just the slope of that.
Let's do the next one.
Was this like the sum and difference rule?
Yeah, this is applying it. This is basically applying all these rules in one. Did we have a constant? Yes. Did we have the power rule? Yes. Did we have coefficients? Yes. And did we have the sum or difference of some terms? So this took all 4 of those rules and applied it to this polynomial. Polynomials are great, right? We keep repeating that power rule. Anybody want to venture a guess at Ryan?
Negative 6x to the 5th,
Good.
plus x cubed over 8. Right? Yeah, that's what I meant.
Okay.
X cubed over 2
Yeah, that's what I meant.
plus,
And then plus 7x.
how about just 7?
Yeah, that's what I meant.
That's what I meant.
Is it okay if you write it 1/2 x?
Sure. 1/2 x to the 3rd is fine.
I have a question though. Since
Yeah.
it's like, there's still a 3 there on the x cubed, would you want us to bring that to the front still or no?
No.
So once you brought one thing to the front, you can't do it anymore?
Okay. We will have multiple derivatives. But right now what we're doing is we're just doing a single derivative. So we're just doing the derivative of each term.
I have a question.
Yeah, Misha.
How did you get the x cubed over? I mean the x
Uh,
cubed over 2. Where's the 2?
So move the 4 to the front and it would become 4x cubed over 8,
Oh, okay.
right? And then that's where we get the half. Okay, horizontal tangents. What are horizontal tangents? That's when m equals 0 or dy dx equals 0, right? Because slope and dy dx are the same thing. Okay,
Can't you just do what we've been doing?
that's exactly what we're doing. We're just going to set it equal to 0. So remember before, you had to do that whole long limit definition. Now we're using the shortcut. So we have 4x cubed.
So can we do this shortcut for any, if they say any, find any like
Yep.
tangent slope?
Yep.
Are we gonna learn how to deal with like
Okay.
Oh
Okay, so here's what we want to do. We want to set this equal to 0. And I can factor out a 4x, and then I would have x squared minus 1. So what does this mean? This means I have 3 tangents. Picture, what are we starting with? We're starting with an x to the 4th. So it probably looks, right, like some kind of W shape. So we have one here, here, and here is pretty much what we're looking at. So we can figure out it's x equals 0, -1, and 1. But if I'm asking for the actual horizontal tangents, that means what are the equations of the line? So let's just go through. So when at x equals 0, how do we actually find the tangent? Plug it back into the original. Okay, so what's the first one? 2. At x equals... No, because the horizontal tangents will be horizontal lines, right? So just y equals 2.
Okay.
But we have 3 of them. What happens when we have -1? -1, it'll be 1 minus 2 plus 2? 1. And what happens when we have at x equals 1? It's also the same thing. So even though there's 3 locations where there's horizontal tangents, we technically only get 2 equations for that.
I like this lesson. I don't really get why we did all that stuff.
Yeah, that's kind of what we did to know like 6 months ago. 6 months ago. Yeah, we were
We have to put it in like points.
Nope, that's fine.
Oh, we don't learn this
I don't know what freaking you
whenever we learn this for the first time, that would be good to know.
No, we did learn it, good job.
See, I was right.
Yeah, we did x over h, that's a derivative.
That's
Like, well,
crazy.
you
It's almost
figured
like I
it
was
out.
I'm
right.
doing this.
Okay. So far, everything that we've done was just a polynomial, and right, we were able to take the derivative of each term. On the next page, we could multiply this all out, but I want you to find the derivative using what we call the product rule. So the product rule, I like this form of it better. So we're picturing u and v are the 2 things we're multiplying together. So basically we take turns taking the derivative of each part. So we'll take the derivative of u, and then we'll keep v the same, plus then we'll keep u the same, take the derivative of v. Okay, sounds a little confusing. It's not, I promise. Here, let's make this u and this v. If 2x plus 1 is u, what would u prime be? What's the derivative of 2x plus 1? 2. Remember, it's just the slope. And I intentionally gave you ones that are just equations of lines to get you used to it. Okay. If v is 3x minus 5, what would v prime be? 3. Okay, so let's put that all together with the formula. So the first part, derivative of u, so that was 2 times 3x minus 5 plus, and then we're going to leave u, 2x plus 1, and what's v prime? 3. So you see what I mean about taking turns? So we like take the derivative of 1, keep the other part the same, then, right, and then do the reverse with the other. It doesn't really matter, like the order, right? You're going to get the same answer. Okay, so let's multiply that out. We get 6x minus 10 plus 6x plus 3. $12x minus 7. Okay. Good?
Yes.
Yes, Ryan.
I'm still kind of confused. But after we like bring one of the degrees like to the front, and we subtract it, you don't do it again. Like,
No. You're just doing it one time. Here's why. Let's say I started with, I don't know, x to the third. Okay, so if I do the derivative one time, I get 3x squared. What happens when I do the next derivative? 6x. What happens when I do the next derivative? 6. What happens when I do the next derivative? Okay, I don't want to keep going in a loop. I'm always going to end up with 0. What good is that going to do me? Nothing. So we only, if we're just asking for the derivative, we stop here and we don't keep going.
that makes sense.
Unless I ask for, which we didn't get to yet. This is the first derivative, this is the second derivative, third derivative, fourth derivative. So we will have higher orders of derivatives, but that's the very last thing. Okay? All right. This is probably the most complex thing we'll do today. I promise. The quotient rule. The quotient rule is a little bit harder to remember than the product rule. So I have this silly little rhyme to help us remember. Okay. This is what it looks like. You're doing the derivative of u divided by v. So we take v times u prime minus u times v prime, all divided by v squared. So I have this low d high take high d low, cross the line and square the low. Sounds complex, but I promise you it will help you remember. Okay, low. Whenever I'm referring to low, I'm referring to the denominator. So you see that? So I'm looking at v. So low, notice it says v. D high means derivative of the top. So that's my u prime. Right? Low, d high, take is my subtraction. High, d low, so that's my u times v prime. Cross the line and square the low. That's my divided. Cross the line is the divided by. And square the low. I know, it's really silly, but I promise.
It sounds more confusing to me than actually.
You think so?
Yeah.
Hey, by all means.
Have you ever thought about becoming a singer and making a song?
Ryan, stop. Okay.
Wait, what's the cross the line?
Cross the line is the divided by.
Oh.
Cross the line is the divided by.
Oh,
Anyway, I know it sounds confusing. I'm just, even me, after all these years, I still think low d high, take high d low, cross the line and square the low. It just helps me remember which one goes first. Low. So low goes first, low d high. So the denominator goes first. So x minus 4. So low d high. So derivative of the top. Derivative of 2x is 2. Take, that's my subtraction. So low d high, take high d low. So high is the 2x. What's the derivative of the bottom? D low, 1. Cross the line and square the low. Again, if you're more one that prefers to just memorize the formula, go for it. I don't care. It's all the same.
Yeah, it'd be kind of
understand your
cool if I
vocab.
could pull this out like I start singing.
Oh, no. Okay.
Low D is like the denominator?
All right, let's
Really funny.
2x minus 8 minus 2x all over x minus 4 squared. Don't bother multiplying out the denominator, okay? Just leave it. What do we end up with? Good. That's it. Okay, so let's find dy dx for x squared plus 4x over x minus 1. There's no other way around this. You have to use the quotient rule for now. There is another way to do the derivative later on, but we won't get to that until next chapter. Okay? Okay, so again, you want to try it on your own and see if we get the same answer? No, Ryan's shaking his head. low, x minus 1. D high, what's the derivative of x squared plus 4x? 2x plus 4. Take high, so that's going to be our x squared plus 4x. D low, what's the...
Plus 4 in a derivative.
Yeah, I was gonna say.
So
The derivative of
the derivative of the top, so that's going to become 2x.
Yeah.
And what's the what's the slope of 4x? Just 4. Remember, anytime it's to the first power, we're just taking the coefficient. Square the line, or cross the line and square the low. That's. Notice I didn't put anything here because the derivative of the bottom is just 1. Okay. Again, we're going to leave the denominator, but the numerator we want to simplify. Now can we finish it, Ryan? Okay. I was going to say, now it's just algebra. Although sometimes when we do calculus, the hardest part is getting the algebra right. Now you could try, when you're all done, factoring, but often it's not going to work out. Yeah, what do we?
No, because we're 4 at the end.
Yeah, what do we get when we in the numerator? X squared minus 2x minus 4.
What? But it
Yeah.
is plus. Oh, yeah. Wait. Oh, yeah, minus 4.
Minus 4.
Where did the x minus 1 go?
So here we did FOIL, right? 2x squared plus 4x minus 2x, that'll be plus 2x minus 4. Distribute the minus x squared minus 4x and combine like terms. Yes, Ryan?
Are you not able to cancel the x minus 1 squared with the x minus 1 originally?
Oh. He asked if we can, I can't even write it. I'm afraid. He asked if we could do this.
No, like the squared.
No, I know what you meant.
She knows.
Why? Oh my gosh. Okay.
Well, because the minus there, because they're not all like factors of the same
They're not all
thing.
multiplied.
If there was an x minus 1 here and an x minus 1 here, different story. But no.
I'll take a picture.
Okay. What time is it? Are we good on time?
20 minutes.
We have 20 minutes for one page? Because it was so straightforward.
This is the last page. Yeah, that's what I'm saying. 20 minutes for one page.
I told you the hardest thing that we did was quotient rule. So if the hardest thing is quotient rule, compare quotient rule to the limit stuff. It's doable, right?
Yeah.
Yeah.
I think I'm finally getting this on.
Low D high, take high D load, right? Low D high. The most important part is knowing which one to put first. So usually what I'll just say is like low D high, because then I know the rest. It's the denominator times the derivative of the numerator first, because often I'll see them switched. Low D high, take high D low, cross the line and square the low.
Is it D high or low?
It's low D high. You just have to get the first part right. The rest of it'll come. Okay. All right.
Yeah, low square. Okay, yeah.
Okay, this is another power rule for negative integers. I will tell you it's exactly the same rule as positive integers. So we practiced with, to the 4th power, to the 5th power. What about 3x to the negative 4? Okay, so that'll be negative 12x. Take 1 away from negative 4. Negative 5, be careful. Yep. And then usually, yeah, it's proper to, sometimes it's weird. The book will sometimes leave it with negative exponents. I will specify, like quizzes or tests, like this is technically simplified form. Good? Okay. Now let's put it to an application. So here we want to find the equation for a tangent to the curve at the given point. What do we need in order to write the equation of a line? We need a point and a slope. And what's the slope? That's going to be your dy dx evaluated at whatever your x value is, right? We did this before, just without the shortcut. Now we have this lovely shortcut to save us time.
How do we know what the point? Oh, because plug it.
Right, so we can find f of negative 2. That's pretty straightforward, right?
Yeah.
That will just be negative 1/8. Okay, let's find f prime of x. Okay, so first thing I would do is I would rewrite 1 over x cubed. Could you technically do quotient rule here? Yes, but don't. It's so much easier just to think of it as x to the negative 3. So what's that going to become? 3x. Good. Or negative 3 over x to the 4th. So now f prime, what do we want to find? F prime of what value? Negative 2. Okay. So that'll be negative 3 over 16. Okay. Now we're just, remember on the quiz I had that problem where I gave you f prime of something equals something and dy, right? Do we have our slope? Do we have our point? Yeah, Maya.
Why do we have to do f of negative 2?
So that we had an x and a y coordinate, right? All I gave you was the x coordinate. Now, sometimes I'll give you the x and the y, but it's,
We need to actually
We have to write the equation.
yeah, because we want to write the equation.
So y.
So y,
1/8
good, plus 1/8 equals
negative
3/16, and then x plus 2. You see why now I don't bother with slope intercept at this point?
Why don't you do it with the? Why don't you do it like with the x?
You can, but
because like that's like like the slope.
that's the, okay,
You know what I'm saying? Like without plugging in.
go away.
negative 2.
Okay, remember this is the equation for the slope at any point x.
Yeah.
So 1 over x cubed, I can find the slope according to that formula. So if I said, what's the slope when x equals 1? You would say it's negative 3. But that would be a different line then, wouldn't it? I didn't answer your question, did I?
Well, I mean, I guess I can just do it this way. I just didn't understand why I can't leave it.
You don't want to have any variables for your slope.
Okay.
Don't leave it, because you actually want to plug in, because why? Negative 3/16 is the slope at this point.
Yeah.
But that's not going to be the slope when x equals 1.
Oh, because it's not for the whole graph, it's for this.
It's for this, so that's why it's very specific
Yeah, okay.
at the given point. Remember, we're looking at curves. If it was the equation of a line, that slope isn't going to change,
Right. Okay.
right? But I'm looking at I'm looking at this as a rational function. I'm going to look at parabolas. I'm going to look at polynomials. And so the tangent is constantly changing its slope. Okay, how do we want to solve this one? Okay, we could do the low d high. We can also rewrite this if you wanted. So you can rewrite, I'll show you. Yeah, I can make this 1/2 x plus 3/2 x to the negative 1 and make that, just use the power rule. That's one option. Does it make sense how I simplified that? Or you could do the low d high, take high d low. We're all going to get the same answer. So if you want to try it that way. So we want to find the point y of 1. What do we get when we plug in 1 to find the point? 2. Okay, and then we want to go from here. Let's find y prime. Oops. Are we okay with that? And then what do we get? No?
I don't get the why it's over 2x.
I skipped a step, sorry. So you understand moving the negative 1 to the front, so that becomes minus 3/2, and then this would be x to the negative 2. So I just kind of put the x to the negative 2 on the bottom. Do you want me to rewrite it? I can rewrite it. That's fine. And it doesn't really matter because what is x? What's x equal in this one? 1. So 1 to any power is just going to be 1. 1.
Hey, I don't get what I'm missing. Why did it go from like to the power of negative 1 to the power of negative 2?
Subtract 1.
Where'd you get the negative 1?
I just rewrote this. 3 over 2x is the same as 3 halves x to the negative 1.
Because
Oh.
we're doing like what we did here. So we did the negative.
Okay, what happens when we plug in 1? We'll get 1 half minus 3 halves, and that gives us. Are we still confused on that one?
No.
Are we good? Okay. We're still confused?
A little bit.
Okay, so let me just remind you, you can also do the quotient rule, right? Low, 2x, d high. So what's the derivative of the numerator? 2x, great. Take high, d low. What's the derivative of the bottom? 2. Cross the line and square the low. Now you're going to see why I rewrote it because it's so much easier. But what happens when I multiply this out? I'm going to get 4x squared minus 2x squared minus 6 over 4x squared. So that's going to give us 2x squared minus 6. Right? We see all that? Take out a 2, so it's going to be x squared minus 3 over 2x squared. Am I missing an x or something? Hold on.
That's what I got, but I was confused by the actual answer.
Oh, no, that's the same thing. Compare this answer to this one. Aren't they the same thing? Just a different way to write it? Right? If you divided this, this would just be a half and then minus. So for me personally, I would choose not to do quotient rule, but it doesn't matter. Plug in 1 here. What do we get if we plug in 1 here? 1 minus 3 will get negative 2 over 2, which is negative 1. But don't we get negative 1 here as well?
For quotient, can you not plug in 1 for x like from the very beginning?
No, don't plug it. Do the formula first and then plug the value in. Okay. Are we all together now?
Yeah.
Okay, so here's our point. Here's our slope. Put it all together. What's that going to be? Y minus 2 equals negative 1. Now, that's not as difficult to put in slope-intercept, but unless I specifically ask for it. Now, sometimes in the book, they'll put it in slope-intercept form. Just keep in mind you don't need to. Okay, last thing. Ryan, because you were asking, why don't we stop? Because they have second and higher order derivatives. You can find the derivative infinitely many times, but certain things like polynomials, like I gave you that example of x to the 4th, after a while you'll just get 0. And then what's the derivative of 0? It's 0. Derivative of 0 is 0. And you could keep going. But there are other types of graphs like sine and cosine that we'll learn that you could keep going with the derivative over and over again. And, right, it's never going to end. Like you can just keep going.
Polynomials are the only ones that keep that.
Polynomials will be the only ones that just end. Okay. And then we'll learn stuff like e to the x and natural log and, there will be like things that you just need to memorize. This is just notation. So notice this is all we've done. This is the first derivative. And it says dy dx. Here's how we write the second derivative. We could do y double prime. Or rewrite, I know it sounds weird to say. It's the second derivative of y with respect to x. And then we have, it's not x squared. It's with respect to x a second time. It looks a little confusing, but that's the notation.
Why Why isn't the 2 after the y? Or like, why isn't the 2 before the x?
Okay, all right. Do you see? This is basically what I'm saying. I'm saying take the derivative of my dy dx. How many d's do you see in the numerator? 2. So that's why it looks like a d squared. It's the second derivative of y. What do you see here? Dx dx. So technically we would kind of picture, what's going on here? We would kind of picture that as a dx squared. We don't put parentheses around it, but that's the implication, okay? Now do you see it? So then take a look at, because you got it. We're taking dx of dy dx. We see it? Okay. Y triple prime looks exactly the same as the second derivative, but with 3. And past 3, what we do is we put the derivative number. So for example, if I'm looking for the 6th derivative, I would just put it like that. It has to be in parentheses because you don't want that to be mistaken for y to the 6th power. Sienna?
This might be stupid, but can I ask why we don't define like the 6th? Yeah, what does that mean?
It's not a stupid question. Okay. So we're going to see some practical applications here. So in terms of instantaneous speed, that's your first derivative. The instantaneous rate of velocity is acceleration. So acceleration is your second derivative. And then the instantaneous change in acceleration actually is the third derivative. That's a, what? It's called the jerk. The jerk. It's why people get car sick is the third derivative, because when you can't anticipate the sudden change in acceleration, does anybody get like car sick or motion sickness? Okay, that's because you're not anticipating the sudden change in acceleration. So see, so it's the jerk that's causing your motion sickness. And those of you that move on to Calc 2 or Calc BC, there are a whole bunch more derivatives, and it's actually used in engineering. It's how we end up approximating things in engineering, like bridges and stuff like that. We actually don't work with exact numbers. It's actually better to have approximations, but we get them to like real exact, and we do that using derivatives. So there really is a real practical application to it. We just don't get to all that stuff just yet. Okay, first 4 derivatives. That was a good question. Did I answer it?
Yeah.
A little bit? Okay. I don't know that it all made sense, but
you answered it.
I answered it. I tried to. Okay. But there is a real purpose for derivatives.
Wait, were you gonna do something else with the y to 6?
No, I was just giving that as an example. So not y to the 6. I just wanted to make sure you knew that has to be in parentheses. So first 4 derivatives. So the first 3 we put the tick marks. After 3 we put the numbers in parentheses. So, okay. What's the first derivative? 3x squared minus 10x. What happens to the plus 2? Goes away. All right, second derivative. We're going to put 2 tick marks. Okay, now we do keep going. So this will be 6x minus 10. And the third derivative, so 3 tick marks, 6. And the fourth derivative, so now I'm going to put that 4 in parentheses, which is just 0. So this took us 4 derivatives to get to 0. Questions? Ryan?
So like on the homework, when we're asked any of these questions,
Just use the shortcut. Yes, Molly.
I don't really get it. Like, I don't know how you got 3x squared minus 10x.
The power rule. Move the 3 to the front, take 1 away from the 3. Move the 2 to...
That to the next one.
Yeah.
and the next
Yep.
one. Oh, okay.
Yeah, Sammy.
Will there be problems where it's asking like, oh, how many derivatives does it take to get to 0?
Not in this class. In BC, yes.
I did.
Seems like a question.
isn't it just like the
plus 1 of the leading? Because it's x.
Yeah, so how many derivatives did it take? So if this is x to the third, it's going to take 4 derivatives to get to 0. If it was x to the fifth, how many would it take to? So, no, 1 more than the power. Okay. We have 2 minutes, 3 minutes, no, 1 minute. I'm fine if you guys want to go. If you have last minute.